There was one more example I wanted to get to from the last video on compound interest, and then we're going to hop into looking at APY versus APR, but it's very related. So let's start with this first example though. Let's say we know a future value. We actually want to have $12,000 3 years from now for a family trip. So we're planning something huge, maybe it's a big anniversary, something like that. How much needs to be deposited now if we're putting in a single amount now into an account earning 4.35% interest compounded monthly in order for us to have enough for the trip? So we have a bunch of different pieces where we can say, okay, cool. Obviously the 4.35 is going to be our R. The 12,000 in this case is not a present value, right? We want to know how much needs to be deposited now. So we're solving for P, the principal, or PV, the present value, sometimes is the phrasing you'll see. So the 12,000 is a future value, FV, and that's the formula that I'm using within Excel. So, everything, even when I give you templates, you can investigate what type of functions I'm using in order to get where I'm going. Okay, the 3 years is, of course, T, and then our monthly compounds, as we've seen before, this is M. So M is 12, right? And again, that's just how many compounds per year. So if we go to our template here, the first one isn't going to give us exactly what we need, right? It's saying, what do you have for the principal? What do you know? So we're going to go down to the second one, solving for the present value or the principal. So we're going to say, okay, I want to have 12,000 in the future. My current interest rate is 0.0435, or again, 4.35 with the percent symbol. And again, if this cuts off, don't worry about it. You can either extend the decimals or just look up in the formula bar. Yes, it still keeps our information. So Excel's not going to change it, other than that weird sort of date issue that we run into sometimes, but that's fixable. Okay, compounds per year, M, we said that was 12. Time in years, so our trip is in 3 years. So we're going to have to deposit at this moment $10,534 and 36 cents. So keep in mind, a quick check on this, did I make this formula correct? Is that right now, what I'm depositing right now should be less than what is needed in the future. So what did I say? 10,534.36. So that means that the interest over the next 3 years is going to be about $1,500 on this, which is pretty nice. Okay, so that's the idea of working backwards. Once you've done one or two of those, they're pretty much all the same. And the template, again, is there to help you out. And in fact, before we get to APY versus APR, I'll just kind of show you. If I click on what I'm solving for here, this output, you'll see up here it says PV. The formula in Excel is PV, present value. If you go up to the total value version of this is where we deposit something, we know the present value, and then we're figuring out future value. Well, it's FV, future value. So those formulas, you don't need to know them necessarily, but they're nice to have in your back pocket in case you need them. Okay, now in this same exact template, let me just resize here so it's a little bit more clear. There's another tab down here, APY. So we're going to use this one in just a minute. And I'll extend that just a bit so we can see what's going on. Okay, so what is APY? Well, APY is basically what you're actually getting as a percentage every year. So when we say, here's the interest rate annually, but it's compounded every month or it's compounded every week, right? That means that the real percentage is actually a little higher than that. So we can solve for APY based on the nominal interest rate, or the APR. We can do that. We can also think about it like, well, if that's my effective rate, if the APY is my real rate, the rate that I'm actually getting, then we can think about it like, okay, I compound once a year at that actual rate. So we can go through and say APY, cool, the 4% is going to be my R, so 0.04. And because I'm using APY, I'm going to let M, my compounds per year, just be 1. So what's the present value? Well, the APY calculator doesn't tell you that. So we're going to go back over to compound interest. We're going to say, oh, we're solving for present value. Cool. So what's the present value of $100,000 10 years from now? So the $100,000 is the value 10 years from now. We want to know what it's worth at this moment. So at an APY of 4%. So we pull this back up. We say, okay, the future value is $100,000. Our APY is 0.04. Our compounds per year, 1, because we're using APY. And then what did we say time was? So time was 10, T was 10 years from now, so 10. So that means that if we have these conditions and we leave the money in there for 10 years, then we only need to have at this moment $67,556.42. So this is another way of thinking about it is inflation, right? So thinking about, well, if we assume there's 4% inflation every year, then $100,000 salary 10 years from now, what is that right now? And it would be $67,556.42. So that's kind of the idea behind that first part. How do we find an APY? So this kind of describes, this gives us a formula to go off of the nominal rate that we talked about, R. Another way to say this is APR, annual percent rate. And so you'll see problems, sometimes I'll throw in here, I'll just remind us, oh yeah, you might see that as APR, fine. So what's the APY for an 8.1% APR compounded monthly? So basically we're saying, what's the real rate, right? What is the actual rate? So let's go over to our APY tab. So the annual percent, I'll see if I can, yeah, it's pretty low. I'll pull that up so we can kind of see both at the same time. So right now, our current rate is 8.1%. And we're compounding 12 times a year. And again, this says 0.08. If you just want to adjust this, then add a decimal on there, right? It doesn't mean it's not there. It just means it's not showing up. But it always shows up in the formula bar here. Okay, so this tells us that our actual rate is, as a decimal, 0.92, and that looks like a mistake. Let's see. Oh, I know why. I know what I did. So this is a 1 plus, and in my formula I had a 1 minus. So we're going to fix this. We're going to update some templates here. So let's try that. Let's see what it looks like. Okay, and now it says 1.08, and that's because I need the -1. So silly for me, just a small mistake, easy to fix. Again, this is part of why I'm doing this for you, because those types of things I can see really easily. I know that the answer should be close to what we started with, right? We started with 8.1%. We should end up, when we find APY, we should find something similar, but it shouldn't be similar and a little bit larger for APY. So when I was seeing 92%, something felt off. So I'll just have to update that real quick. Okay, so then we go back over here and we say, okay, the real percentage, the APY, is going to be 8.408. Again, just depends on how many decimal places you want to go to. In this case, we've got 3. And then we say, okay, well, what's the present value of $100,000 10 years from now at an APR of 4% compounded monthly? So this is very similar to the first example in this portion, right? Except there we were given an APY, so we only did the one compound. Here we're given monthly compounds, so we're going to say, okay, it does look very similar, but M is going to be 12, of course, our classic friend, our most common one. So let's go back over to the template, and we're going to go back over to the compound interest tab, and we're solving for present value or principal. So the 100,000 is still there. The 4% is still there. The only thing that's going to change is we've got monthly compounds. So here we've got 67,076. So I just want to show that again. If there's one compound a year, it's 67. I'm just going to put it off to the side, 556.42. Okay, if we compound 12 times a year, then we've got 67,076. So let's think about it. If I were to, think about it like investing this money now. I want $100,000 10 years from now. Would it be better for me if it compounded once a year or 12 times a year for the same percent rate? Well, more compounds are better, for sure. So this number, this present value is smaller. This means I would have to deposit $500 fewer dollars right now in order to get to that 100,000 versus if I only compounded once a year. So it makes sense that this present value is actually smaller because the interest is working for us, basically. That's kind of the concept there. So anyway, that's another example of just using that solving for the present value. And right, APY, again, the biggest thing is just think about APY is this is the actual rate you're getting. So when you see APR, it's like, yeah, okay, but that's not accounting for compounds. So taking 4%, compounding monthly, we bump up to 8.408%. The other thing I should mention here is that we could keep this as one compound a year and just update the annual percent rate based off of what we found. So we just found that the APY for this, I should say this was that we can't use this one, but we could certainly find the APY for 4% and plug that in place of this annual interest rate. But we could do that to check. We don't really need to do that now. So anyway, that's the idea. I would strongly encourage getting used to working with the templates, trying to find a certain level of comfort with them. And if you're struggling at all with those, please just let me know. Ask questions in class. Help each other out working through those pieces. But I'm trying to make this the mathematical heavy lifting like pretty easy for you. All right.